Good morning, my dear students. In this lecture video, I am going to start a new module, that is module number 3 in FEM subject. The module name is what? The beams and shaft and torsion of a shaft. Okay. So again, in this module, we have the two categories. That is, one belongs to the beam and shaft, and one more is belong to the shaft. Okay. So this is the syllabus. Okay. So beams and shafts. So that is, we need to study about the what are the different types of boundary condition which is applicable to what beams, and the load vector, Hermite shape function, beam stiffness matrix based on the Euler-Bernoulli beam theory, examples on a cantilever beam, probed cantilever beam, numerical problems on simply supported fixed straight and stepped beam using the direct stiffness method with concentrated and uniformly distributed load. Okay, so in this topic you are going to study what is a beam and what is the importance of beam in the engineering structure. Okay, so in the engineering in the engineering field, and what are the different types of beams you are going to use. Okay, and numerical problems on that, and you need to derive the shape function of a beam element and Hermite shape function of a beam element. Okay, so already we studied in the shape function. Okay, so that in model number 2, what the one dimensional element, two noded dimensional element, that is a triangular, tetrahedral, hexahedral, all those element we already derived the shape function. Okay, so shape function is nothing but to find the field variable of a given problem. Okay, so coming to the second part here, the torsion of shaft. Again here we have to derive the element stiffness matrix for torsion, that is also called as a finite element formulation of a shaft, and determination of stresses and twisted in the circular shaft. Okay, so that means what? Numerical known stresses. Okay, that is a twisted circular shaft we need to solve. Okay, so here in the module 3 you have to remember only thing what is beam and what is the importance of beam in the present engineering days. Okay, and what are the different types of beams you need to study in this. Okay, so here let me understand what you mean by beam. Okay, introduction to beam. Okay, so normally look at this diagram first. Okay, beam nothing but what? It is a long slender structure. Okay, such type of element we are going to call as beam. Okay, so here the now see the definition of beam is: a beam is a long slender structural member whose cross sectional dimensions are relatively smaller than its length is called as beam. Okay, so it is a long slender member whose dimension of the length is very small. Okay, so such type of element you are going to call as beam. Okay, so here look at the definition I wrote here. A beam is a long slender structure. Okay, so this is a long slender structure or a rod or a given element whose cross section area, look at this rod cross section area is smaller than its length. Okay, such type of component you are going to call as beam. Okay, or it is a one dimensional structure in which the loads are applied in radially direction. Okay, so here we are going to apply the loads in the beams are radially direction, that is transverse direction. Okay, so beam can be straight or curved. Okay, so the beam may be either this shape, that is a straight, or the curved shape. Okay, with a constant depth throughout the length of the length, or the depth can be very with the according to the length. Okay, such type of element you are going to call as beam. Okay, so beam commonly subjected to a transverse loading to produce a significant of bending moment. Okay, so present day the beams are used almost everywhere. Okay, that is a building, bridges, automobile, and airplane structure. Okay, so that is the definition of beam. Or if you say another definition means a beam is a horizontal structural member in which the length is considerably larger. So here look at this element. Okay, so this is a beam element. So here in this element the length of the beam is very larger. Okay, and consider the what larger than the other two dimensions, that is the breadth and width. Okay, so look at here, the breadth and width is very smaller as compared to this the length. Okay, so such type of component we are going to call as beam element. So beam is a horizontal structural member in which the length is considerably larger than other two dimensions like breadth and width. Okay, such type of component we are going to call as beam. Okay, so here the components of beams are there, that is a footing, column, beam, slab. Okay, so here the bottom safe, that is the bottom place we are going to call as the footing, upon which the column is going to be fixed. Okay, upon which the beam will be there. Okay, so this element we are going to call as beam. Okay, look at here, observe this component. Okay, so beam is a long slender structure or rod or component, so whose length is considerably larger. Okay, so as compared to breadth and width, the larger length will be there. Such type of component we are going to call as beam. Okay, so this component is called as a beam. Okay, so you have to remember this beam. Okay, so what are the different types of beams you are going to use in FEMs or in the present chapter is. So according to the type of this end support, okay, so depending upon the support we are going to classify the beams again. Okay, simply supported beam. Supported beam means what? Here, look at here, only the simply supported will be there here. Okay, so here it is a fixed is there, here ruler is there. Okay, so such type of element you are going, such type of the component you are going to call as simply supported beam. Okay, so here simply supported beam is supported at the both the end. One end of the beam is supported by hinge and another end is supported by ruler support. Okay, so this support allows the horizontal movement of the beam, and it beam beam maybe undergoes the both the shear stresses and bending moment. Okay, so here ruler support is nothing but what? The moment of the this rod or the structure will takes place along the x direction. Okay, so such type of component we are going to call as ruler support. Okay, fix here there is no movement. Okay, there is not any deformation present in this. Okay, a force is acting on this beam element. Okay, such type of diagram you are going to call as what? Simply supported beam. Okay, coming to the continuous beam. Okay, so in the continuous beam, a beam on which a uniformly distributed load is act toward the beam, such type of component or such type of the element you are going to call as continuous beam element. Okay, so look at here diagram. So full the length of the element, the continuous what a uniformly distributed load is acting on that. That is this beam is similar to the simply supported beam, except more than two supports are used on it. Okay, so one end of it is supported by a hinged support and the other end is a ruler support. Okay, same as done in the simply supported beam. Okay, or one or more supports are be used between these beams. Okay, it is used in long concrete bridges where length of the bridge is too large. Okay, so this type of the beams we are going to use where the large bridges will be there. Okay, so such type of beams we are going to call as continuous beam. Okay, so look at here, this diagram is called as a continuous beam. Okay, coming to the overhang beam. Okay, so look at this diagram. So here one end is fixed the roller support, that this extra is called as overhanging. Okay, so look at this extra is called as overhanging. Such type of the portion or such type of the beam you are going to call as overhang beam element. Okay, so overhang beam is a combination of simply supported beam and cantilever beam. Okay, so one or both the end of the overhanging of this beam. Okay, so this beam is supported by a roller support between the two ends. Okay, this type of the beam has heritage properties of the cantilever and simply supported beam. Okay, just to understand that it is a combination of simply supported beam and the cantilever beam. Okay, so here the name is given overhang beam here because, so look at here, so this portion, from this portion to this portion is, it is just hanging to the at node number 2 or support number 2, this ruler support. Okay, such type of beam element you are going to call as overhanging beam element. Okay, so coming to the cantilever beam, all of you know this cantilever beam means what? So one end is fixed, another end is free. Okay, so here the load going to act, such type of element you are going to call as cantilever beam. Okay, so cantilever beam is a structure member of which one end is fixed and another end is free. Okay, so this is one of the famous type of the beam used in the trusses bridge. Okay, almost everywhere we are going to use this. Okay, so this beam carries a load over the span, okay, which undergoes the both the shear and bending moment here. Okay, so here look at this, this is a rod. Okay, this is the element, so one end is completely fixed this side and this side is free. Okay, here the load going to act on this element, so here because of load the deformation takes place. Okay, so such type of element you are going to call as cantilever beam. Okay, coming to the fixed beam, so as the name indicates, fixed nothing but both the ends is going to fixed. Okay, such type of element you are going to call as fixed beam element. Okay, so this beam is fixed from the both the end, so it does not allow the vertical moment and the rotation of the beam element. Here there is no any vertical moment and horizontal moment. Okay, so it is only under the shear stresses and no bending moment here. Okay, only the shear stress acting on this element and it produce okay, so because of fixed. Okay, and it is used in the trusses and other structure element you are going to call as a beam element. Okay, what the fixed beam. Okay, coming to the trusses beam, already we studied in the module 2, so already we solved the numerical problems on this truss element. Okay, so a beam is strengthened by adding a cable or a rod of form a truss is called as trussed beam. Okay, so here number of bar element is connected to each other. Okay, so here number of more number of elements are connected through welded joints or rivet anymore. Okay, so anything we can connect, so such type of beam we are going to call as trussed beam. Here the more number of load act on that particular element, only the at node. Okay, so coming to the, that is the first category level. So coming to the second category level, depending upon the type of the load. Okay, so on which load we are going to act. Okay, so such type of element what we are going to classify further. Okay, so one is what, the here the beams are classified based on what. So here according to the type of the support. Second one is according to the type of load acting. Okay, so according to the type of load. Okay, so look at here the point load. Okay, this such type of beam element you are going to call as a point load. So here point is, here load is acting. Okay, so a point load is nothing but what, it is an equivalent load applied to the single point which can determined by the calculating the total load over the object surface or the length and the attributing the entire load and its center. Okay, determine the total length or area which is load to be applied. Okay, so here load is acting on this element. Okay, just this is for example I am showing you. This is the one end, this is another end, this is fixed, and this is the roller support, and the total length is okay, a load, exactly load is acting in the middle of this to determine the total length. Means okay, here the half length is L by 2. Okay, just to understand that point load nothing but what, it is the equivalent load applied to the entire beam. Okay, the total structure, such type of load we are going to call as point load. Okay, coming to the uniformly distributed load, means here the entire load. Okay, so this is the beam, so the at starting point to the end point, a load is acting uniformly. Okay, here it will not varying. Okay, so here such type of beams you are going to call as uniform distributed load. Look at here. Okay, so here all the point a UDL, that is what uniform distributed load is acting on this element. Okay, so such type of loading we are going to call as uniform distributed load element. Okay, coming to the UVL. Okay, as the name indicate UVL, so UVL stands for uniform varying load. Okay, so here look at here, the load is acting uniformly here. Okay, so it is varying the load. Okay, such type of loading condition we are going to call as uniform varying load. Okay, so coming to the this. Okay, so this is very important to solve the numerical problems on beam element. So this point, this slide is very important to solve numerical problems. Okay, which is going to solve in upcoming lecture video. Okay, so look at this is a schematic diagram of the beam element. Okay, so look at here the beam element. On each beam element here there will be 2 degree of freedom. Okay, so here the vertical. Okay, this is what the translation degree of freedom. This is the rotational freedom, rotational theta 1 is the rotational vertical. Okay, so this is the point load, this is the area of cross section, this is the uniform distributed load can be act on that element. Okay, so reaction support. Okay, so this is the what length of element. Okay, just to understand that in a given beam element. Okay, so at each node a one vertical, that is what translation degree of freedom, and one theta 1 rotational, this symbol, this is called as rotation. Okay, v1 theta 1 you have to remember this. Okay, and at node number 2 v2 theta 2, these 2 points you have to remember to solve the numerical problems on beam element. Okay, so what is the beam and its application? I already told you. Okay, so beams are used everywhere. Okay, that is the building, construction of what are the bridges. Okay, automobile sector or aircraft. Okay, so apart from the supporting the commercial and residential construction, I-beams are also used to construct the frame for a trolley, ways, elevator, trailer. Okay, trucks, beds. Okay, everywhere you are going to use. Okay, apart from the construction field. Okay, so what are the beams used in engineering structure means? Okay, so beams are used to support the weight of the floor, okay, ceiling and roof of the building, and to the transfer the load to the vertical load bearing the element of the structure. Okay, so these are some of the, apart from the engineering application, these are the some of the applications we are going to use the beam element in the present day. Okay, so this very important. From this slide you have to understand that what you mean by beam, what are the different types of beam, and what are the degree of freedom present in the beam element. Okay, so in the next class we are moving to solve the shape function for the beam element. Okay, so I hope you understand this. Okay, so just to understand from this lecture video, beam is a long slender structural member whose length is considerably larger as compared to the width and breadth. Okay, such type of component we are going to call as a beam. Okay, depending upon the given load or given shape or given support, we are going to have beams are classified into different ways. Okay, for your syllabus, simply supported, cantilever beam, overhanging beam, proped beam, okay, and UDL, UVL. Okay, on these beams you are having a numerical problems on that element, you need to study those beams. Okay, so I hope you understand this. Okay, thank you very much.